beginning with question 36. We need to find out which two functions are inverses of each other. And so you'll recall that if you plug in x, the function for x of the first function, you will find that they equal x after you simplify it. So in question 36, the ones that appear to be inverses are g and h. And I'm going to test that by plugging in h for x in g. So when I simplify this, I should get x. Here's what happens. I have the fifth root of x minus 11, and I'm plugging that in for x in g, in h. So I'm raising this to the fifth power plus 11. And so when I raise that to the fifth power, I get x minus 11 plus 11, and you know that negative 11 plus 11 is equal to x. So since x equals x, g and h are inverses of each other, and that would be choice A. So choice A is the right one for this piece. Make it a little bit smaller so we can fill in an answer key here. This was choice A. And likewise for 37, I'm going to take a look at just kind of estimating which one is going to be equal to x when I plug one in. So if I think about solving this one for x, there seems to be a 5 missing here. So let me plug that in. What I want to do is to take a look at g. G has multiplication. F and h both have division. G has addition, so the opposite is going to be subtraction. So I'm going to test h once again. So as I plug that in, let me make that just a little bigger so I can have a little more room. I'm going to plug in g, the value of h. So in place of this x, I'm going to use this value. So here is how that looks. So 3 times x minus 5 divided by 3 plus 5. And if I get x, these two are inverses. So the 3's cancel, and I get x minus 5 plus 5. And you know that that's equal to x, because negative 5 plus 5 is 0. So since this is equal to x, I can see that these two are indeed inverses. So my choice, g and h are inverses, is choice A again. Again, you'll notice that all the answers, the correct answers are A. That's definitely not the way it is on the test, so just kind of be prepared. In number 38, tell whether the relation is a function. So in this problem, we have a set of ordered pairs. This relation is negative 2, negative 7, 3, negative 3, 5, negative 7, 7, negative 8, and 11, 7. So you can see all of the x values are different. This would not be a function if two different x values gave you the same y. So now let's examine the y. This is 7, 3, negative 7, negative 8, and negative 7. So one of the things that we could do is to graph this. So if we went -2, -7 on a graph, that would be in the third quadrant. But that would not be a vertical to any of the other pieces. So again, I'm going to encourage you to graph this on a coordinate plane and use the vertical line test. So stop the graph if you need to, but you should be able to see that this is a function. And likewise with 39, the x values do not repeat. But again, if you need to graph this, by all means do that and use the vertical line test. This is a function. So if you need to stop the video and graph these, you can see that it will pass the vertical line test. Now we get to question number 40. -8 goes to -1, but -8 also goes to 6. This is where this function fails the vertical line test. This is not a function. If you're having trouble with that, graph those ordered pairs on a coordinate plane and use the vertical line test. Okay, so we're going to graph this function. Explain why we chose. So the original function is the parent graph, x squared. So x squared is this graph. It starts at 0, 0, and it comes up here at 1, 1, and at 2 it goes to 4, and at 3 it goes to 9, and so forth. So this is a parabola, and a parabola on this side as well. So I was having a little trouble getting my dots in the right places, so I wanted you to see at 2 it's 4, at 3 it's 9. So at 1 it's negative, at -1 it's 1, at -2 it's 4, at -3 it's 9. So here is my parent graph, and that looks like this. Now, the question asks us to graph this using transformations. So what I'm looking for in this is to see if you know what this adding 2 does and what this subtracting 5 does. And so what you're going to say is that we're going to move this equation, we're going to translate this equation spots down. Because of the negative, because of the -5. And 2 units left because in the parentheses moves opposite. Or something to that effect. But the bottom line is my new vertex is not going to be 0, 0, but is going to be, you can see here, it's going to be left 2 and down 5. And this has to do with vertex. So remember I went 1 over and 1 up, 1 over and 1 up. Then I'm going 2 over and 4 up. So I'm going to go 2 over and 4 up. And so this is just a translation. So 2 over and 4 up. And so this is going to be my new graph. And that is our translations. Okay, 42. Again, I'm going to start with this parent graph. 0, 0, 1, 1, because it's a squared function, 2, 4, 3, 9. And then the reflection over the y-axis of that is going to look like this. Is a parabola, a curve. So that is the parent graph. Now remember, the one outside the parentheses moves your function down or up, in this case up 2 units. So this means up 2. And this piece moves your function right and left. In this case, it will be left 2, because remember, in the parentheses is opposite of what's kind of instinctive. So this is going to be left 6 units. So your new vertex is negative 6, 2. Okay, so this is going to be the parabola that you're moving. So this would be an alternate way to explain your work there. So I'm going to move this vertex up 2 units and left 6 units. So here is my new vertex, and I'm going to use the symmetry. It was over 1, up 1, left 1, up 1. It was over 2, up 4, and over 2, up 4. And I could go over 3, up 9, but that's 4, 5, 6, 7. So that's going to be off the grid. So we're going to make this work like this. So this would be an alternate way to explain this. This indicates that this is left 6 units, and this indicates that this is up 2 units. So that would be the explanation for that one. So let's get it back in the picture here. On page 12, it's a long study guide, but their problems are kind of spread out. So here we're going to find the relative maxima and minima. A maximum, this piece would actually go on forever there, go on forever there. This would be a relative maxima. This would be a relative minima. And so we would write that the relative max of this is going to be 0, 1, or you could write 1 if it's a maximum value. Now, it says minimum, so we want the ordered pair. So the ordered pair, so the value of that is 1. And if they ask for the value of that, they're looking for the y value. So the minimum, and there's only one relative minimum, this is a maximum. We like to use shorthand in math. And so that would be 2, negative 3. And again, if they ask for the value of that one would be negative 3. So minimum and maximum values. Okay, one more question, 44. Use the leading coefficient test to determine the end behavior of a polynomial function. Basically, if you have an even function and you have a positive leading coefficient is going to start up. If you have a negative exponent, the coefficient will, so here's kind of the review. This is a positive leading coefficient. This one would be a negative leading coefficient. And these are for odd functions. If odd functions start down, they have a positive leading coefficient. If odd functions start up, they have a negative leading coefficient. Now let's talk about even functions. So these are odd and even. Even functions have a positive leading coefficient if they start up and end up. So they have a positive leading coefficient. And if even functions are odd, they're going to start down and end down. This would be a fourth degree function, but it's going to be a negative leading coefficient. So pretty basic stuff. But you can see that the one in question is going to have a fourth degree. So it is going to start up and end up. So it couldn't be this one, and it couldn't be this one because those are both odd functions. The only two it could be are choices A and B. It's not going to be B because this one starts down and ends down, so that would be a negative leading coefficient. So it is going to be choice A, and you can graph this one. Use your graphing calculator to finish that up. Okay, good luck on your test. Make sure this is complete before turning in.